Today we are going to discuss divisibility rules. Right, so before going into that, let us do a quick recap of what we studied in the last class and why do we need these rules in place. Right, say in the last class we were discussing about factors and multiples. Multiples are quite simple, we just have to write the tables. So 3, the multiples of 3 are 3, 6, 9, 12 and so on. The multiples of 2 are 2, 4, 6, 8 and so on. Right, but if I have factors, especially for large numbers, so then it is pretty time consuming. Say if I have to compute the factors of 32, right? So what is the process that we discussed? So the first process is start with the smallest number, that is 1. So 1 times 32 is 32. So identify factor pairs. So we started with 1 and tried to find out what number should I multiply 1 with to get 32. So this is the first factor pair. Then we try to find the second number or start it with the next number. So 2. So what number should I multiply 2 to get 32? So 16. If we divide, we'll get the answer as 16. So this is the another factor pair. Then we'll check with 3. Right. So for 3, again if we check, so we'll see that we have a remainder. So it is not divisible by 3. With 4, we'll see 4 8s are 32. Right. With 5, we'll check 5 8s are 40, 5 8s are 40 or 5 6 are 30, so it will leave a remainder, right? So it is not divisible by 5. With 6, it is not divisible. With 7, it is not divisible. With 8, it is again divisible. So 8 times 4 is 32, right? So again, we are repeating the same thing. So I'll just stop finding factor anymore. So I'll stop here. No need to consider this because 4 and 8 and 4 are the same pair of factors. So the factor of 32 are 1, 2, 4, 8, 16 and 32. Right. So this was when we had to compute the factor of 32. What if we have even larger number and if we are asked to find whether 2 is a factor of that number, whether 3 is a factor of that number, whether 7 is a factor of that number. So it will take a large amount of time to test all these numbers and divide them one by one. Right. So what we need is we need a quick rule or we need a quick shortcut to check whether a number is divisible by a given number or not. Right. So that is where divisibility rules come into picture. Right. So first of all, what is divisibility? Divisibility means that we can divide a whole number by another number without actually having a remainder. Right. So the remainder must be 0. So if I say 4, so the divisibility of 4 by 2 would mean if I divide this by 2, I should get 0 as the remainder. Right. And then what are divisibility rules? So divisibility rules are the set of rules that helps us understand whether a number is divisible or not without actually dividing that number. Right. So let us see by considering 2 as an example. So what is the divisibility rule for 2? So the divisibility rule for 2 says that a number is divisible by 2 if its last digit is even, say 0, 2, 4, 6 or 8. Right. So if I have this number 45628 or 45,628, I am asked whether 2 is a factor of this number or not, right? So instead of dividing this with 2, dividing the whole number with 2 and wasting a lot of time in that process, what we'll do, we'll just check this digit, the unit digit. So this should be divisible by 2. So if this is divisible by 2, then the entire number would be divisible by 2, right? So again, if we have another number 2, 9, 6, 8, 4, 3, again a large number, and if we are asked whether 2 is a factor of this number or not, so we can just check the unit digit and then ask, is 3 divisible by 2? 3 is not divisible by 2, so this entire number will not be divisible by 2. So again, just to check divisibility by 2, we just need to focus on the unit digit. If that is even, which is either 0, 2, 4, 6, 8, then it is divisible by 2. If it is odd, then it is not divisible by 2. Okay. Then we move on to the divisibility rule for 3. So a number is divisible by 3 if the sum of all the digits is divisible by 3 or a multiple of 3. right? So we have 15,324. So we have to check whether 3 is a factor of this number or not. So first of all, we can quickly check whether 2 is a factor of this number or not. 2 is a factor because the last digit is 4. Now we want to check whether 3 is a factor of this number or not, right? So without actually dividing it, there is a way to see whether 3 is a factor or not. So what we do is we just add these digits. So 1 plus 5 plus 3 plus 2 plus 4. So 1 plus 5 is 6, 6 plus 3 is 9, 9 plus 2 is 11, 11 plus 4 is 15. So we got 15. Now we see that is 15 a multiple of 3 or is 3 a factor of 15? Right? Instead of checking for this number, we check for this number. Right? So this has simplified our calculation. Right? So what we did is we added those digits and then checked whether 3 is a factor of this number or not. We know that 3 is a factor of 15 because 3 5s are 15. Right? So that means this entire number is divisible by 3 or 3 is a factor of this number. Again, another example 22486. We have to check whether this number is divisible by 3 or not. Again, if you just check the unit digit, it is even, so it is divisible by 2. Right? Now for 3, we have to add these digits. So 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16, 16 plus 6 is 22. Now instead of checking whether this is divisible by 3 or not, we just check whether this is divisible by 3 or not. So we know that 3 is not a factor of 22. So this number will not be a factor of 22. Right? Now, I mean, this is a unique case wherein if I have this number, the sum is coming out to be 15. If I have this number, the sum is coming out to be 22. But this is not the case always. You will not get the sum as the first two digits all the time. Right? So may get, if I take one more example, 242. Right? So here, if you look at this, or 2428. Right? So 8 plus 2 is 10, 10 plus 4 is 14, 14 plus 2 is 16. Right? So it is not always that you'll get this as the sum, right? So 2, again 16, we are getting this as 16, so 3 is not a factor of this number. Okay. Next we have the divisibility rule for 4. So for 2, what did we check? We checked the unit digit, right? And then we saw whether this was even or not. For 4, we'll check the unit and the tens digit, or the first two digits, right? This is also known as first two digits from the right, right? Or the last two digits, right? So a number is divisible by 4 if its last two digits form a number that is divisible by 4, or if its last two digits are both zeros. So when we want to check, so for example, if you want to check for 2 again, this is the last digit which is even. So this is a multiple of 2, or 2 is a factor of this number. If we want to check with 3, we just have to add these digits and then check whether 3 is a factor of their sum or not. Now if I have to check for 4, I look at this 2 digit. So this 2 digit must be either 0 0, so it must be either 0 0 or must be a factor of 4. So this has simplified the division process for us. Instead of dividing this entire thing with 4, we just have to check whether this 2 digit is divisible by 4, or say whether 16 is divisible by 4, right? So since 16 is divisible by 4, so this is 4 is a factor of this number. Similarly, for this number, if you see, the last two digits are 0. So that is why this is also a multiple of 4, or 4 is a factor of this number. Okay. Another example, 22816. Right. So we just have to check whether the last two digit is a factor of 4. So here also the last two digit is a factor of 4. So this entire number is a multiple of 4, or 4 is a factor of this entire number. Right. Then we move on to the divisibility rule for 5. So a number is divisible by 5 if its last digit is 0 or 5. Right? So if you just look at the last digit again for 5, and if it is either 0 or 5, then this entire number is divisible by 5. Again, we don't have to divide the entire number by 5, just look at the last digit. If it is divisible by 5, which means if it is either 5 or 0, that means the entire number is divisible by 5. So if you are asked whether 5 is a factor of this number, we will say yes, because the last digit is 5. Similarly, 22819. If you look at the last digit, it is not 0 or 5. So for a number to be divisible by 5, it must be either 0 or 5, right? So since it is not 0 or 5, that is why 5 is not a factor of this number. Okay. Then we have the divisibility rule for 6. For 6, we don't have to go and check anything specific to 6. We just have to check if that number is divisible by 2 and it is divisible by 3. So for a number to be divisible by 6, the number must be divisible by 2 as well as 3. So we'll check the divisibility rule for 2, right, which is the last digit must be even. And then we'll check the divisibility rule for 3, which means the sum of the digits must be a multiple of 3, right, or must be divisible by 3. If both of these conditions hold true, then we'll say the number is divisible by 6. For example, 246. If we have to check this number is divisible by 6 or not. First of all, we'll try to see with 2. So the last digit is 6, which is even, so it is 2 is a factor. Then we check with 3. For 3, we'll have to just add the digits. So 6 plus 4 is 10, 10 plus 2 is 12. 12 is divisible by 3, so 3 is also a factor of this number. So when the number is divisible by both 2 and 3, it is also divisible by 6. Okay. So to check if a number is divisible by 3, we check it should be divisible by 2 first and also by 3. Okay. Then we move on to the divisibility rule for 7. Right. So to test whether a number is divisible by 7, the last digit of the given number should be multiplied by 2 and then subtracted with the rest of the number, leaving the last digit. So, I mean, we don't use this much, but it is good to know this logic as well. So, if we have a number, say 2, 4, 7, right? So, and 1, right? So, 2471, 2471. We have to check whether 7 is a factor of this number or not, right? So, what do we do? So, first of all, multiply this by 2. So, take the unit digit, multiply this by 2. So, we got 2, right? And then we subtract this 2 from this number. So, we subtract this 2 from 247. So, with rest of the number leaving the last digit. So, we'll just leave the last digit and subtract this with 247. We subtract 2 from this, we'll get 245, right? And then we just divide this with 7. So if this is divisible by 7, that means this number 7 is a factor of this number. Okay. We can again check, I mean, if we don't want to divide this with 7, we'll again do the same process. So 245, right? Multiply this with 2. So 5 times 2, which is 10. Then subtract this with 24. So 24 minus 10, which is 14. Right? So 14 is divisible by 2, which means, sorry, 14 is divisible by 7, which means 245 is also divisible by 7. And 245 is divisible by 7, which means 247 is also divisible by 7. Right? So 2471 is divisible by 7. And 7 is a factor of 2471. So we can apply this rule repeatedly as well. So for example, if in the first instance we are getting a number larger, we can reapply that divisibility rule to see if that number is divisible by 7 or not. We don't have to divide. Okay. Then we have the divisibility rule for 8. So notice there is a pattern here. If we have to check the divisibility rule for 2, the last digit must be even or it must be a multiple of 2, right? Or 2 must be a factor of the last digit. If it is divisible by 4, we check the last 2 digits. So the last 2 digit 4 must be a factor of the last 2 digit. Now if you have to check for 8, so 8 must be a factor of the last three digits. So for 2, look at the last digit. For 4, look at the last two digits. For 8, look at the last three digits. So now we just have to check whether, instead of checking this entire thing, 53208, right, which is a large number, we just have to check whether 208 is divisible by 8 or not. Or if the last digit is 0 as well, then also it is divisible by 8, right? So for 2, again, just to remind you, for 2, the last digit is 0, 2, 4, 6 and 8. If we have to check for 4, then we take the last two digits. So the last two digit can either be 0, 0 or any multiple of 4. For 8, the last three digits should be 0, 0, 0 and the others must be a multiple of 8, right? So for 2, just look at the last digit. For 4, look at the last two digits. And for 8, look at the last three digits. For 9, 9 and 3 is simple. So we just add the digits and then check if it is divisible by 9 or not, right? For example, if you have this number 27324, we have 2 plus 7 plus 3 plus 2 plus 4, which is 18. So 18 is divisible by 9. 9 twos are 18. So 9 is a factor of this as well. Okay, again, we are not dividing this entire number. We just added the digits and then quickly checked whether 9 divides this number or not. Right? And then 10 is similar to 5. When we used to check the divisibility rule for 5, we just check the last digit. It must be either 5 or 0. For 10, we check that the last digit must be 0. So if it is 0, then only it is divisible by 10. Okay. Okay, so we'll now quickly revise this rule and then see if this rule applies to all of. So we'll just take a digit and then test using this rule whether that number is divisible by these digits or not, or try finding the factor of that number. Okay. So an integer is divisible by 2 if it ends in 0, 2, 4, 6 or 8. So we look at the unit digit. If an integer is divisible by 3 if the sum of the digits is divisible by 3. An integer is divisible by 4 if the last two digits are divisible by 4. An integer is divisible by 5 if it ends in either 0 or 5. Right? It is divisible by 6 if it is divisible by both 2 and 3. Right? If it is divisible by 7 after manipulation. So by manipulation, I mean doing some changes. So 243, what changes we did? So if I have 243, what we did is we took this unit digit, so this is 3. We took this unit digit, multiplied this with 2. So 3 times 2. This gave us 6, right? Now we subtract this 6 from this 24. So 24 minus 6 gave us 18, right? So is 18 divisible by 7? No, it is not. So 243 will also not be divisible by 7. So this is how we check the divisibility rule for 7. 7 is the only odd one out here. Otherwise, others are much more simple, right? A number is divisible by 8 if the last three digits are divisible by 8. A number is divisible by 9 if the sum of the digits is divisible by 9. And a number is divisible by 10 if the last digit is 0. Right? We also have divisibility rule for 11, 12, 14 and so on. Right? But we'll stick till 10. Right? Because most of the questions we usually get, or we have to find the factors till 10 only. Right? So there is also a divisibility rule for 11. And we can just know this for the sake of understanding. So 1, 2, 1, 5, 8, 6, right? So what does the divisibility rule for 11 say? So add alternating digits. So first digit, second digit, first digit, third digit, fifth digit, right? So alternating digits and then add another set of alternating digits, right? So if you add this, 1 plus 1 is 2, 2 plus 8 is 10, right? Then for the other one is 2 plus 5 is 7, 7 plus 6 is 13. right? So you got the sum of one alternating pair as 10, the sum of other alternating pairs as 13, right? Then you just subtract these two. So if you subtract these two, you get 3, right? Now you just have to check if their difference is a multiple of 11 or 0. So it should be either 0 or a multiple of 11. Okay, since it is not a multiple of 11 or 0, so that means this number is not divisible by 11, right? We can also take in a number that is divisible by 11 to quickly check this out. So we have 1, 2, 1, 9, 9. Let us take this number. Okay, so the first pair we have 1 plus 1 and then plus 9. So 1 plus 1 is 2, 2 plus 9 is 11. And then we have the other pair 2 plus 9 only, right? So 2 plus 9 is 11. If you subtract these two, we get 11 minus 11, which is 0. Since it is coming out to be 0, that means this number must be divisible by 11. Okay. So, I mean, why did we study these rules? To find factors very quickly, right? So when we are given a number and we need to find the factors of that number, we'd like to find that factors very quickly without actually dividing those numbers, right? Let us look at an example and then see if we are able to apply those concepts that we studied, right? Say for example, we are given a number 2688, right? We need to find some of the factors of this number, or say we need to find factors, or we are asked whether 2 is a factor of that number, 3 is a factor of that number, 4 is a factor of that number, 7 is a factor of that number, right? So, and we have two options: either we divide that with that number or apply the divisibility rule to check whether that number is divisible or not, right? So again, we can apply the divisibility rules to get the answer quickly, right? So 2688 is the number. So first of all, we'll check with 2 because 1 is already a factor, so we'll check with 2. For 2, we'll just check the unit digit or the last digit, which is 8, right? So it is an even number, so it is divisible by 2. Then we can check with 3. So we have 6 plus 2, which is 8. 8 plus 8 is 16. 16 plus 8 is 24. So we got the sum as 24. Now we can either directly divide this by 24 or add this further. So 4 plus 2 is 6. Right? And then we can check whether this is divisible by 3. So since this is divisible by 3, which means this is also divisible by 3, which means this is also divisible by 3. Right? So we can apply the divisibility rule to the numbers that we even get after adding. Right? So this is the power of divisibility rule. So it is also divisible by 3. Then we can check with 4. Right? For 4, what was the rule? We just have to look at the last two digits. So we'll look at 88. Right? So 88, is this divisible by 4? So here we have to divide. So now see, instead of dividing this entire number, we just have to divide the last two digits. Right? So 4 2s are 8. So it gets cancelled, 8 comes down, and then 4 2s are 8. So yeah, it is divisible. Right? And then, so it is divisible by 4 as well. Next we can check with 5. So 5 will check the unit digit, right? So if we check the unit digit, is that unit digit 0 or 5? No, it is not, right? So for a number to be divisible by 5, the unit digit must be either 0 or 5. So since it is not divisible by 5. Then we can check with 6. What was the rule for 6? We don't have any rule, we just have to check it should be divisible by both 2 and 3. If it is divisible by 2 and not by 3, then it is not divisible by 6. So it has to be divisible by both 2 and 3 at the same time. So since it is divisible by both 2 and 3, it is divisible by 6 as well. Then we can check for 7. What was the rule for 7? We just have to multiply this unit digit by 2. So 8 times 2 is 16. And then subtract it to the remaining digits. So 268 minus 16. So we'll get 2 here, we'll get 5, and then we'll get 2. Right, so again we will not be dividing this entire thing, we'll again follow the same process. So we just have to check this is divisible by 7. So what we'll do, we'll apply the same process again, multiply this with 2. So 2 times 2 is 4, right? So we subtract this 4 from 25, so we get 21. Now we know 21 is divisible by 7. So this is a fact, 7 is a factor of 21, 7 is a factor of 252, which means 7 is a factor of 2688 as well. Then we can check with 8, right? To check with 8, we have to check the last 3 digits is divisible by 8. So 688, we have to divide this with 8. So 8 8s are 64. So 4 comes here and then we have 8. So 8 6 are 48, which means it is divisible by 8. Right, then we can check with 9. For 9 we have to add the digits. So when we added those digits we got 24. So is 24 divisible by 9? No, it is not. Right, so that is why 9 is not a factor. For 10, what we did, we just looked at the unit digit, right? So for a number to be divisible by 10, the unit digit must be 0. So here the unit digit is not 0. So which means 10 is also not a factor. Right, then we can check with 11. So we form a first alternate pair, so which is 2 and 8. So 2 plus 8 is 10. Then we have another alternate pair, 6 and 8. So 6 plus 8 is 14. We then subtract these two. So we subtract larger from the smaller. Sorry, smaller from the larger. So 14 minus 10 gives us 4. 4 is not neither 0 nor a multiple of 11. So that is why 11 is also not a factor. Right. So this small trick is very, very powerful, and we'll see its power in the subsequent class when we discuss how do we find factors of any given number, right, using the factor tree. So then, first of all, we have to identify, just like we used to test, whether it is divisible by 1, then 2, then 3, and so on. You don't have to go on and divide one by one. We can first quickly check whether it is divisible, then only we divide, otherwise we skip the division process. Okay, so we'll start with building factor trees in the next class. So again, we have moved one step closer to computing HCF and LCM, but prior to that, we should know how to find the factors of numbers, right, or any numbers that are given to us.